So for 10.2, let's look at a new thing that we're going to be talking about, which is a combination. A combination is an arrangement in which order is not important. For example, lottery numbers. If you pick lottery numbers, it doesn't matter what order you pick the numbers in, it just matters that you have that order. So just as a reminder, the definition of a permutation then is an arrangement in which the order is important. So for example, the letters on your license plate. So your license plate, the order of the letters and numbers is important. So the order is important there. So what we're going to do is I'm going to give you a list of 8 different things, and in your groups I want you to pause the video and determine whether or not these are combinations or permutations. So is the order important or is the order not important? You do not have to write them down, just talk about them as a class. So the first one, a classroom seating chart, the order does matter because where I put you does make a difference. So that is going to be considered a permutation. Number 2, finding the diagonal of a polygon. So for example, if I give you this quadrilateral, you can find the diagonal going either that way or that way. I don't care. So the polygon, the order is not important, so that would be a combination. Number 3, the batting order of the Pittsburgh Pirates or any baseball team. Order does make a difference, so that is considered a permutation. Number 4, 10 books on a library shelf. Books on a library shelf are organized alphabetically by author, so order does matter, so that is permutation. Number 5, a hand of 5 cards from a deck of 52 cards. That is a combination. It doesn't matter what order the cards are in, just as long as you have them. Number 6, a 7-person committee from your class. Remember, a committee does not have specific order or rank, so that's also going to be a combination. Because it doesn't matter which order I pick you to be on the committee, you're on the committee, so that's the important part. Number 7, first, second, and third chairs out of 6 clarinets from a band. Order does matter there, so that is a permutation. And then number 8, 6 outfits chosen from 14 to be modeled. So it doesn't matter which order you pick the outfits, those 6 are still going to be picked no matter what, so that is a combination. So like permutations, we have a formula for combination. So the formula for combination is C of n choose R, or remember we can also write the big C with n and R next to it, is going to be n factorial over n minus R factorial times R factorial. So the combination, you're multiplying by R factorial in the denominator, whereas permutation you're not. So let's do some examples. Number 1 is 5 combination 2. So we are going to plug in 5 factorial over n minus r. So 5 minus 2 is 3 factorial times r factorial, which is 2. So if you notice, my 3 factorial and my 2 factorial should add up to the top, which is 5. So that's going to be 5 times 4 times 3 times 2 times 1, all over 3 times 2 times 1 times 2 times 1. So let's simplify what we can. My 1's will all reduce, those 2's reduce, and my 3's reduce. And then I'm still left with a 2 in the denominator, but I have a 4. So 2 goes into 4 2 times. So I'm left with 5 times 2, which comes out to 10. So there are 10 different combinations that I can make. Number 2 is 10 combination 5. So that is going to be 10 factorial over 10 minus 5, which is 5 factorial, and then r, which is 5 factorial. So that is going to be 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1, all over 5, 4, 3, 2, 1 times 5, 4, 3, 2, 1. So 5 all the way down to 1 is going to reduce, and then let's reduce everything else. That 1 reduces. 2 and 3 turn into 6, so we can reduce with that. And then 4 goes into 8 2 times, and 5 goes into 10 2 times. So I'm going to be left with 2 times 9 times 2 times 7, and that's going to be it. So I'm going to be left with 252 combinations. Number 3, 12 combination 7. So this is going to be 12 factorial over 12 minus 7 is 5 factorial, 7 factorial. So that's going to be 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all the way 5, 4, 3, 2, 1, 7, 6, 5, 4, 3, 2, 1. So everything up to 7 is going to reduce. That 1 reduces. So let's see what else. 2 and 4 turn into 8. 3 goes into 9 3 times, and 5 goes into 10 2 times. So we're left with a 12, 11, a 2, and a 3. So all of that is going to multiply to 792. Number 4 is 10p4, so this is actually a permutation. So it's going to be 10 factorial over 10 minus 4 factorial, which is 6 factorial. So all of that is going to come out to, the 6 is going to reduce, 6 all the way to 1 is going to reduce, so we're going to be left with 10, 9, 8, 7, and then 6, 5, 4, 3, 2, 1 all reduce. So that all multiplies out to 5,040. So we will be using multiple formulas here. Number 5, I'm going to take 2 combinations and then multiply them. So we have to do both combinations and then multiply them out so we can figure out what it all comes out to. So the first one is going to be 12 factorial over 12 minus 4 is 8 factorial, 4 factorial, times 8 combination 3. That's going to be 8 factorial over 5 factorial, 3 factorial. So I know that 8 is going to cancel out with my 12 factorial all the way from 8 to 1. So I'm going to be left with 12, 11, 10, 9. And I haven't worked with my 4 factorial, so I need to still write it as 4, 3, 2, 1. And then we're going to multiply that by, I know the 5 and the 8, so that's going to be 8, 7, 6. And then I'm still left with 3, 2, 1. So reduce first where you can. And then let's reduce some more. The 1s are going to just go away because anything over 1, we don't need to do that. So let's see here. I have a 3 and a 2 here, and that turns into a 6. I also have a 4 and a 2, and that turns into an 8, so we can cross-reduce with that 8. And then I have a 3, which goes into 9 3 times. So I'm left with 12, 11, 10, 3, and a 7. So when I multiply all of that out, it turns into 495 times 56. Or I'm sorry. The whole thing comes out to 27,720. Not each one individually. So I want you guys to do the exact same thing for number 6. Okay, so number 6 is going to be 9 factorial over 6 factorial 3 factorial times 6 factorial over 4 factorial 2 factorial. So let's reduce where we can. I know that the 6 all the way down to 1 is going to reduce. So from the 9, I'm going to be left with 9, 8, 7, and then the 3 is 3, 2, 1, times. I know the 6 and the 4 are going to reduce, and I'll be left with 6 times 5, all over 2 factorial, which is 2 times 1. So then let's reduce where else we can. The 1s, we don't need to multiply by 1. 2 is going to go into 6 3 times. The 3s are going to reduce, and 2 can go into 8 4 times. So I'll be left with 9 times 4 times 7 times 5, which should all come out to 1,260. So the last thing I want to do is some word problems like we did in the previous lesson. So example 1, I want to know how many committees of 5 students can be selected from a class of 25. So we have 25 students total. Now because this is a committee, the order doesn't matter. So as long as you're on the committee, you're on the committee. And I can only choose 5. So it's going to be a combination of 25, and we're going to do combination 5. So using our formula, that is 25 factorial over 25 minus 5 is 20 factorial, and then r factorial, which is 5. Now the 20 all the way down to 1 is going to reduce, so let's not write all of it out. But we will be left with 25 times 24, 23, 22, and 21. And then the 5 is going to be 5, 4, 3, 2, 1. So then let's reduce what we have left over. The 5 goes into 25 5 times. 4 goes into 24 6 times. 2 goes into 22 11 times, and 3 goes into 21 7 times. So we're going to be left with 5, 6, 23, 11, and 7, which all multiplies out to 53,130. Example 2, how many ways can first, second, and third place be awarded if 20 people are running in a race? Now, first, second, and third place, the order obviously matters here. So that's going to be a permutation. So we have 20 people racing. We're taking a permutation, and we only have 3 places, so we can only pick 3 at a time. So that's going to be 20 factorial over 20 minus 3, which is 17 factorial. 17 all the way down to 1 are going to reduce. So this is going to be 20, 19, 18, And when you multiply all of those, you are going to get 6,840 different ways first, second, and third place could be awarded. Okay, example 3. A box contains 12 black and 8 green marbles. How many ways can 3 black and 2 green be chosen? So we have 2 different combinations here because the order 1 does not matter, but we're looking at black marbles and green marbles. So we have to do a combination for each. So we first have 12 black, so we're going to do 12 combination, and we want to pick 3 of them. And whenever you're doing 2, you end up multiplying, so that's going to be times. We have 8 green, so that's going to be 8 combination, and we want to pick 2. So that's going to be 12 factorial over 12 minus 3 is 9 factorial, 3 factorial, times 8 factorial over 6 factorial, 2 factorial. So let's reduce first where we can. The 12 and the 9 are going to reduce from 9 all the way to 1, so that's going to be 12, 11, 10 over 3, 2, 1. And the 8 and 6 are going to reduce all the way down from 6, so that's going to leave us with 8 times 7 all over 2 times 1. Okay, 2 goes into 8 4 times, we don't need the 1. 2 goes into 10 5 times, and 3 goes into 12 4 times. So we're left with 4, 11, 5, 4, 7, which all comes out to 6,160 different ways we can pull marbles. Okay. Number 4. Why don't you guys do this one on your own? It's almost exactly the same as 3. I'll leave 3 up for you. We have 12 boys and 10 girls, and I want to make a committee, meaning order doesn't matter, of 5 boys and 5 girls. So go ahead and do that one for me. Okay, so because we're looking at committees and we have boys and girls, then we have 12 boys to choose from and we want to pick 5, times 10 girls to choose from and we want to also pick 5. So this is going to be 12 factorial over 12 minus 5 gives me 7 factorial, 5 factorial, times 10 factorial over 5 factorial, 5 factorial. So with the 12, 7 all the way down is going to reduce, so that's going to be 12, 11, 10, 9, 8, all over 5, 4, 3, 2, 1. And then the 10 and all the way down to 5 will reduce, so 10, 9, 8, 7, 6, and then we still have 5, 4, 3, 2, 1. So let's reduce some more. 2 and 3 reduced to 6. 4 goes into 8 twice, and 5 goes into 10 twice. On this side, 2 and 4 turn into an 8. 3 goes into 9 3 times, and 5 goes into 10 twice. And then we're just left with the 1s. So we have 12 times 11 times 2 times 3 times 2 times 9 times 2 times 7, which should come out to 199,584. And that is the difference between a combination versus a permutation.